Actually, the purpose of my video today is to shed more light on linear regression in machine learning and linear regression within statistical framework. I'm actually going to say the two are not the same. Of course, the two are not the same because the one within statistical framework actually had intention of explaining relationship, okay, and why the one within machine learning framework, actually tailored towards prediction. And I remember I mentioned in my previous videos that you know explanatory goal is different from predictive goal, and explanative power does not translate into predictive power. So I'll first start by giving example of you know the linear regression within statistical framework I mentioned the other time. The focus is going to be on explaining relationship between the outcome and independent variable. I'm actually going to give an example. Maybe we want to look at the effects of the amount spent on advertising, okay, on this on sales. So in that, what we're trying to do is just like we want to know the effects of the amount spent on advertising on that. So that does not necessarily mean we want to use it to predict. Of course, we know correlation does not imply causation. So I just want you to see that in that way, that we just want to explain relationship. So explaining um relationship in that regard, like looking at the effects of that particular variable, then we're actually going to seek redress using what I call model explanation approach. Okay, the model explanation approach, where the variation around the response variable sales will be splitted. So, and we actually want to isolate, the contribution, the percentage variation in that sales that will be explained by the amount spent advertising. Now, in that regard, linear regression within statistical framework, we start with, you specifying the model. And of course, in the model, there's going to be an error component where assumptions would evolve around it, and the estimation of parameters will be involved, like estimating the slope, estimating the intercept, and of course, you know, we actually going to estimate that, putting into consideration that assumptions hold. At the end of the day, we're also going to, obtain the p-value associated with the regression coefficient. We test hypothesis testing, we construct confidence interval, and of course, we apply model selection criteria in case you have more than one independent variable. All of that is statistical. We are doing all of that. We are constructing confidence interval based on, on the slope or on the intercept, because we are actually pursuing an explanatory goal, okay, which is not a predictive goal. Okay, so on the other hand, if you want to, if you're seeking, predictive goal, an example, maybe you want to, a company is interested, in predicting, say prices of a house, okay, and they have data set containing information on various houses, including their features and the corresponding say prices. So here we are not the company is not interested in the effect of all these risk factors on the sales price, but what they want is you know uh prediction. They actually want prediction. Okay, now because they are pursuing a predictive goal. Okay, the linear regression within machine learning will actually be appropriate, and they call that linear algorithm, so which is a conventional linear regression. So what we're going to do, since prediction is involved, we're actually going to split our data. You remember when you are pursuing that within statistical framework, you are not going to do any splitting at all. Don't forget that the central limit theorem even requires that we should work with large samples. So the idea of a splitting doesn't really, it's not going to come in when we are actually pursuing an explanatory goal using statistical framework. So, but because we are pursuing a predictive goal, we're using linear regression within machine learning algorithm, our data, we're actually going to split to training and testing, and we believe that we will learn the linear, I will train the linear regression algorithm on the training set, and we're actually going to validate the model using the test set. So, unlike in linear regression, we estimate parameters using either method of maximum likelihood, or we're using the method of least squared. Of course, the idea behind that is just to minimize the error in the model. But in the um, machine learning framework, we actually going to train a linear regression model using the training data, with intention to optimize a loss function. Okay. And when I say optimizing a loss function, it actually means a mean square error. Okay. And that will be done, to minimize the difference between what the model eventually predicted and the actual prices. Of course, splitting the data, we already know the status of the test, you know. So with that will be actual prices. So we want to minimize the gap between the predicted and the actual prices. So if you're doing that, you're actually minimizing the mean square error. And of course, they will evaluate the model performance on the testing data, just like what I says, and they're assessing metrics like the mean absolute error or root mean square error, to measure how well, the model predicts house prices on the data that you don't see. Okay, so the focus will actually be on building a predictive model. Okay, a predictive model that have a tendency, to generalize well to new data, without necessarily, okay, interpreting the coefficient or making statistical inferences about the relationship between predictor and the house prices. So I'm actually, I want to believe you now understand, the difference between the linear regression within statistical framework and the linear regression within machine learning framework. I'm not going to say one is better, but the one to use depend on your intention on whether you actually want to predict or you want to explain. Okay.